Okay, this video we're going to find out the molar mass of a substance, okay, and also calculate the relative atomic mass. So basically the concept is very similar, okay. We have to write equation, write down the data, but this time, okay, we have an extractions of solutions from a stock solution, say 250 cm cube. I take out 25 from it. So therefore, okay, I emphasize, okay, this for example emphasize the L shape, okay, the usage of the data, arrange them in an L shape, helping you to do the math, okay. So we find number of mole of A, okay, number of mole of B in 25 cm cube. Normally, okay, the titration will be in 25 cm cube. I put bracket because it's not a must for that. So we use mole ratio for that, and then we will find the number of mole of B in 250 cm cube. So therefore, we have an extraction issues here, and then we're going to find out the answers, okay. So let's have a look right here. We'll have the first part, H2X dibasic acid with 2H, okay, and then we're going to add NaOH in it, okay, because there is 2H here, so you know that the ratio will be 1 to 2, okay. So we have like the data, 2 gram first dissolved in water, make up to 250, so you have 2 gram here, 2 gram, and then dissolve in 250 cm cube. We are not titrating NaOH against this 250 cm cube H2X. We are taking out 25 cm cube. So I will write 25 cm cube here. Okay, and then this required 0.1 m NaOH and also 31.8 cm cube of NaOH. So we are titrating against this one. So I will write these data, okay, just next to it. So therefore you know that, okay, actually we are using NaOH to doing with this 25 cm cube, but not others, but not this one or this one, okay. So this will be the titrant, this will be the analyte, okay. So basically right here, okay, we will know that this one, okay, will be the number of mole of A, okay, and then we can use mole ratio for B, and then we'll move up to 250, and then we'll just go up to find out the X, okay. The direction will be like this, okay. I always call this one L shape, okay, because normally you start from here and then you go to the left, okay, and then one step upwards, one level upwards, okay, and then we're going to find the original one, okay. So number 3, okay, so we're going to calculate the number of mole of A. So number of mole of NaOH, okay, that will be 0.1 m times V, okay. So remember the volume have to be in dm cube, okay. So this one will be 3.18 times 10 to negative 3 mole. Okay, and then next, very important, is number of mole B in 25 cm cube. So remember, you have to mention very clearly, because H2X, you got quite a number of different number of mole here, here, and here. Maybe the number of mole are different, okay? So you have to tell the others clearly, okay? You're talking about 25 cm cube. So it is a must to write things like this. If you didn't write this, okay, in exam, I will have mark deduction for you, okay? So 3.18 times 10 to negative 3, where the ratio is 2 to 1. So divided by 2, 除自己乘人哋 divided by 2 times 1, okay? So this one will then become 1.59 times 10 to the negative 3 mole. Okay, and then number 5, okay, we're going to find H2X. This time it's not in 25 cm cube. We're going to move it up, okay? So we'll move up to this one, okay? We'll move up to 250 cm cube. So basically, okay, in 250 cm cube, okay, we'll have the original, oh, sorry, not this one. Original, okay, that will be from 25. Okay, remember you are starting from here, 25, and then going up. So this 1.59 times 10 to negative 3, we're talking about this 25 cm cube. Okay, so we divided 25 times 250 because we know that the number of mole have to be more, okay? So we'll divide the original by 25 and then times 250 here, okay? So right here, okay, it will be 0.0159 mole. Okay, so next, alright, this 0.0159 mole is talking about this 250. So all this solid dissolved in water, the number of moles should be the same. So what next? Okay, what we're going to do? Okay, we're going to find out the molar mass. Okay, remember number of mole of 250 cm cubes. Okay, the number of mole H2X in 250 cm cube, it will be equal to the mass over molar mass of H2X. Okay, so basically, okay, you can solve this by arranging the data like this. The mass will be 2 gram, okay, H2X, because, well, we're finding the molar mass of H2X, so you can directly say the molar mass, okay, of H2X, so it can be you just write like this will be okay. You're not finding X in this case. So anyway, molar mass of H2X, so 2 divided by 0.0159, okay, so you got something like 125.8 gram per mole. Okay, got it? So in case you still don't know what happenings right here, okay, so this one is 2 gram, okay, we put this number of mole into a conical flask, which is 250, so 250, so you'll find that the number of mole of this one should be equal to the number of mole of this one. But when you take out 25 cm cube, the number of mole of this one will decrease, okay, because you just take portion of 250, okay, you just take a 1/10 of it, so therefore you have 1/10 of number of mole right there, okay, and then you do the titration. So all the way when you go backward, okay, so you have mole ratio, find out this number of mole. When you go up, you have to times 10, okay, and then because this one's equals, so I just write the number of mole in 250 equals to mass over molar mass, okay. So next, okay, that will be sales practice 19.9, okay. So this one we have H2X dissolved in water to make up to 250 and then 25. You see, it's so common, okay. The question is very similar most of the time. So you have like 5.92 gram, okay, you dissolve in 250 and then you just take out 25 cm cube and you deal with 0.5 m NaOH, and then will be 18.5 cm cube. So basically the first one, it will be the number of mole of NaOH, that will be 0.5 times 18.5 over 1000. Remember, you have to do the math on your own first, okay. If you start to find that you know what doing, okay, so don't just go through the videos on your own, okay, you have to do it first. So H3X, okay, in 25 cm cube, okay, because you go from this box, go to this box, so therefore it will be a mole ratio. The ratio of, because it's H3X, sorry, so it will be 1:3 ratio. So, okay, I forgot doing the ratio part, okay. Make sure you have the ratio part, okay, this is 3. Okay, and then next, 9.25 times 10 to negative 3 divided by 3 times 1. So the answer for this one will be 3.08 times 10 to negative 3 mole. And then after 25 cm cube, you're going to find number of mole of H3X. Yeah, so many mistakes. Or in 250 cm cube. So you have this one in 25. So 3.08 first divided by 25, then times 250. So this one will be 0.0308 mole. And then we're going to find the molar mass of the acid. So the molar mass, mass over molar mass equals to the number of mole of H3X in 250 cm cube. So you have 5.92 over mm equals to 0.0308. So molar mass of H3X will then equals to 192 gram per mole. Remember, it is a molar mass, so it will be the unit gram per mole. Okay, next, that will be the calculation of relative atomic mass. Actually, more or less it's the same. Okay, you read the question, you will see. So you have mass dissolve in up to 100 cm cube, and you take 10 cm cube this time, okay, and then you titrate against HCl and then use the M and V like this way. So you're going to find the molar mass first, and then you're going to find the relative atomic mass. Easy. So you have number 1, M2CO3. This M have to be M1 positive charge, okay, and you combine with HCl. Okay, the ratio should be 1 to 2 because I know that this is plus, so this one should be negative. So you got 2m here, so you have 2 Cl. Okay, so 1.14 gram, you have like 100 cm cube, and have 10 cm cube. We titrate this 10 cm cube against with HCl, so that will be 0.085m, and then we have 25.3 cm cube. Okay, so this is part 2. Number 3, number of mole of HCl will be equals to 0.085 times 0.0253, okay, which will equals to 2.15 times 10 to negative 3 mole. Okay, and then we're going to find this one and then go to 10 cm cube. Okay, so will be M2CO3 in 10 cm cube. Okay, this one is very important. Okay, will equals to 2.15 times 10 to negative 3. Divide it yourself times others. Divide by 2 times 1. So this one, the answers will be 1.08 times 10 to negative 3 mole. Okay, and then number 5, that will be M2CO3 in 100 cm cube. Because originally it's 10, okay, now become 100. So 1.08 times 10 to negative 3. First divided by 10 and then multiply by 100. So this one would be 0.0108 mole. And then number 6, that will be the molar mass. Okay, so mass over molar mass equals to number of mole of M2CO3 in 100 cm cube. Okay, so this one, the mass will be 1.14 over M2CO3 equals to 0.0108. Better to present should be mm of M2CO3. Okay, don't be lazy. Okay, mm of M2CO3, will that be equals to 106.0 gram per mole. Okay, so that will be the first part A answer, molar mass of M2CO3. Part B, basically, where you just have like M times 2 plus C plus O times 3 equals to 106. Then you can solve the problems easily. Okay, so M, okay, it should be 23. Okay, so you just write relative atomic mass of M is 23 gram per mole. Okay, this one is relative atomic mass, so you should not have a unit for that. Okay, relative atomic mass has unitless. Okay, so that's all for this question. Last one. Okay, do remember, pause the videos, okay, and try to do it out on your own. Okay, so MOH bracket 2, 2.6 gram dissolve in 250. Okay, and you take out 25 against, okay, 1/10 out of it. You have HCl, okay, and that will be the volume. Okay, this time we directly find out the relative atomic mass of M. So basically the first one, MOH bracket 2, HCl ratio should be 1 to 2, so 2.6 gram, 250, and then 25 cm cube. Okay, and then you find out 0.1 m and then 30.4 cm cube. Okay, and then this is number 3, 2 here. Number of mole of HCl. So you see that it's so mechanic, okay, the whole calculation. You just need to practice a little bit more, okay, so you'll get familiar with the step. The step is more or less the same all the time, okay. Most of the question is exactly the same, but you really need to work out this L shape clearly so that you know that, okay, that will be number of mole, find out mole ratio, and then going up like this way. Then the whole things will be more systematic, okay. Chem calculation is more or less just like this. So repeating, okay, and later on you'll find that it's so boring. So this one, okay, divided by 2 times 1. So the answer for this part, okay, that will be 1.52 times 10 to negative 3. Okay, and then number 5, number of mole of MOH bracket 2 in 250. Original is 25. This one is related to 25, become 250. So therefore you divided the original first that will be 25, and then times the new one, 250. So it will be 0.0152 mole. Okay, and then number 6, okay, you're going to find out the mass over, okay, that will be m plus 16 plus 1 times 2. Okay, you see that expressing the molar mass of MOH, okay, into a formula like this. Okay, and then we just put down 0.0152. Okay, so the mass, okay, we have used is 2.6. So 2.6 over 0.0152 equals to m plus 17 times 2. Okay, so after you solve it, okay, you'll find that the answer for this one have to be 137.1. Okay, so that will be the relative atomic mass. So you'll find that no unit at all. Okay, so that will be like that. Okay, so summary. This videos we learned about calculations of molar mass and relative atomic mass. More or less, okay, the steps are exactly the same. Remember the data, okay, because it is not just one solutions and then do titrations. Okay, we have extracting part of it, okay, from stock solution. So better to arrange them in L shape. So find A first and find B. Remember, have to be in 25 cm cube, and then you have another B, which is 250 cm cube, and finally you do the calculation. Why I always say that, okay, it's very important to write it in L shape. You can have a look of examples right here. So this is a typical L shape, so you know that the step like this way. If you just mess up the position of this data, you write something like this, then at that time, okay, after you find out this one, then you have to think, oh, I go here, or I go here. Okay, so the correct answer have to be here. Then you will make the whole thing very confusing. Okay, so better to arrange them in the same level. If the titration is happening, okay, between these two, then you arrange them in same level. Then you know that, okay, you trace, okay, the directions, okay, have to be to the left first, okay, to the left first, okay, and then going up, and you find a question mark here. Okay, so that's all for this video. Bye bye.